Okay, so today's going to be a real brief introduction into trig integrals. Should be the next section in Calc 2. And basically the whole point of this section is to be able to integrate powers of trig functions. So we know how to do the integral of sine and cosine, and then from the last couple of videos we could do secant and tangent, and there were some others. But what if we have some more of these? What about like sine squared x? Or secant to the fourth power x, or something like this. So that's what we're going to be talking about today. And there's two things that we need to remind ourselves of. There's two trig identities that become really, really, really helpful here. The first one is the Pythagorean identity. And there's really three forms of it that you need to know. This is the most common one. This is the easiest one. And I'm going to go through these real quick because these aren't supposed to be super thorough. If you notice, the first thing I'm going to do in this identity is I'm going to divide everything by sine squared x. What happens when I do that? I get 1 here. Cosine over sine is cotangent, and it's squared. And then 1 over sine is cosecant, and it's squared. This is the other identity. And then to get the third Pythagorean identity, I actually did this in one of the other videos, I'm going to divide by cosine squared. If I do the same thing to everything in the equation, it stays the same, so I can do that. I get tangent plus squared plus 1 is 1 over cosine is secant squared. And so these three identities are the ones you need to know. In fact, just so they all look the same, I'm going to rewrite this in white. You have to know these. The last identity we're going to talk about, I'm not going to prove to you. I'm just going to state it. And we can talk about it if you want to know why this works. And these are the half angles. And the two forms of this that you need to know are to simplify sine squared x and cosine squared x. And they all look pretty much the same. Sine squared x is going to be 1/2 outside 1 minus cosine of 2x. And then cosine is going to look basically the same. It's the exact same thing but with a plus in the middle. And so once you have these 5 identities, you're basically good to go. I think any others like the double angle or anything like that is probably a little bit excessive, but just in case you do need it, we can talk about that at another point. So, in fact, some of these allow us to integrate more things immediately. So, for example, I'm gonna actually put this aside. For example, we can actually integrate sine squared x like really easily because we actually have another form that's so much easier. This is the integral of 1/2 1 minus cosine 2x. I can take the 1/2 out and then integrate everything separately. I'm doing a couple steps at a time. Please pause if it doesn't make sense. I have the antiderivative of 1 is x. Antiderivative of minus cosine is minus sine. Because of that 2x, I have to throw a half out, though. So that's a half x minus, I'm distributing, a quarter sine of 2x plus c. Okay, so the next thing we're going to do is they're going to fly by pretty quick because you're going to get practice much later. This is just kind of to dip your toe in the water. We're going to talk more sort of big picture here. When I have powers of sine and cosine and secant and tangent that are much higher, Let's give an example. What's a good one? So all of the questions from this section are going to be some power of sine times some power of cosine, or some power of cosecant times some power of cotangent, and then some power of secant times some power of tangent. There are two things to do, two methods that you need to know. One of them will be u sub, and one of them will be these sort of power reducing formulas. Here I actually notice this is already ready to do a u sub. If I let u equal tangent x, then its derivative, which is secant squared, is already right there. Du is secant squared x dx, and I can just sub it in. This is the integral of u to the fourth, tangent to the fourth, du. That's u5 over 5 plus c, and I can sub that back in. U to the fifth, u is tangent, and there we go. Except now, let's do a different kind of example. What if it's not secant squared, but it's secant to the fourth? Essentially, what the trick is to be able to try to force a u sub to work by keeping these Pythagorean identities in mind. So we're going to go through the example here. If I wanted to let u equal tangent x, I can only take out two secants. So what I want to do is I want to break off two of the secants that can get sort of eaten up by the u substitution. So I'll do secant squared x and secant squared x. This one I'm sort of reserving for the u sub, because that's going to go away. But with the other stuff, with the other secant squared, I can actually use this and turn them into tangents. So by the Pythagorean one, the third one, I can replace that other secant squared with a 1 plus tangent squared. And now I can actually do this u sub I wanted to do. Because I've turned everything else into tangents, I can get rid of this from my u sub, and this becomes u to the fourth 1 plus u squared du. This is the integral of u to the fourth plus u to the sixth, which is u5 over 5 plus u7 over 7, and then you can sub that in. I won't write the parentheses. And there it is. So just because these are supposed to be real short, I'm only going to do one more example. But this is just to sort of give you the idea of what we're trying to do. Let's do... Okay, so just like before, my first step is to try to figure out what my u sub is going to be in advance. We need to sort of force that u sub to work. And what I'm going to, just because these videos are supposed to be short, I'm not going to go through in detail why I chose this. These choices are just going to start to become natural to you once you do a bunch of these. I think u equals cosine x is the best way to go. And the reason, just briefly, is because if I set u equal cosine x, I need to set aside one sine x to get eaten up by the u sub. That will leave me 4 sine x's left. I can turn all 4 of those sine x's into cosines, which I can replace with u using the Pythagorean identity. So let's actually do it. Cosine x, sorry, cosine squared is here, And then just like before, I'm going to take out my sine x that I know is going to go away from the u sub. How many do I have left? I have sine to the fourth. And now sine to the fourth, I have something in terms of sine squared. Here, if I subtract cosine squared, I know sine squared is 1 minus cosine squared. So I can rewrite this times. Well, this is sine squared x squared. And sine squared is 1 minus cosine squared. See how I did that? Please pause it if it doesn't make sense, if the algebra doesn't. And then I've got another sine x. Now this u sub actually works, because I've got only cosine x's. Got it here and I've got here. And I can now throw out this sine x from the u sub. Remember, du is negative sine x dx, because that's the derivative. So I can throw in that negative sign, can throw in another negative sign, and I get negative integral u squared times 1 minus u squared squared. And now it looks kind of gross, but it's actually just a power rule if I simplify. It becomes u squared. I'm going to FOIL this out. 1 minus 2u squared plus u to the fourth. If it helps you, you might want to write out that foiling. Negative integral u squared minus 2u to the fourth plus u to the sixth. Now I'll distribute this negative sign. Negative u squared plus 2u to the fourth minus u to the sixth. Just a power rule. Negative u cubed over 3 plus 2u to the fifth over 5 minus u to the seventh over 7 plus c. And now I can throw in u equals cosine. Remember, that was my u sub. This is negative cosine cubed x over 3 plus 2 cosine to the fifth x over 5 minus cosine to the seventh x over 7. Okay, and there we go. That's our answer. So this video ended up being really long, and I'm sorry about that. But moral of the story is this section is going to be about practice, practice, practice. These are the steps that are the hardest. It's seeing this step, figuring out what the u sub is and how you need to take stuff out to make it work. And that just comes with practice. So we'll get more of that, and I'll certainly make more practice videos for you. Okay?